Hello everyone, welcome to my channel. I hope you all are doing good, taking good care of yourselves. I wish you all a very happy Lori. I hope you all are fit and fine. So today we are going to start a new chapter that is nitrogen containing compounds. Okay, uh, you can share this session meanwhile. Okay, we are waiting for another 1 minute. You can share this session among your friends, also in the respective groups. So today is 13th of January. Okay, so we have around 17 to 18 days left in this month, and on 26th of February is your exam. So we have more or less around 50 days. If I exclude your practical exams also and your other project in Viva, then we have nearly 50 days to prepare for exam. I hope you are studying well, you're studying hard, and are not wasting your time. Okay. If there is any problem in video or audio, you can let me know. In the previous video, the mic got switched off in between, but nobody informed me. That is why the remaining 5 to 7 minutes portion is without any audio. So if you want that I should make another video for that part, you can let me know, or you can just solve those questions. Okay. So we are not waiting so much. We are starting with a chapter. So if I see, we have done haloalkanes, haloarenes, we have done alcohols, phenols, we have done aldehydes, ketones, and carboxylic acid. More or less, we have done around 20 marks organic chemistry. We have done. Okay, 20 marks we have covered. Just two chapters are left. Nitrogen containing compounds that will be around 6 to 7 marks, and we have biomolecules for 3 to 4 marks. Only these chapters are left, which we will be able to complete, I think, by 28th of January. We will be able to do that. So we are starting with a new chapter that is nitrogen containing compounds. Today is the theory session, day number 14 of revision series, organic nitrogen containing compounds, lesson number 1. That, and we are going to do theory today. Okay, we are going to do theory today. Without wasting any time, let us start with the chapter. Okay. If you have any doubt, any problem, you can let me know. Let us begin. This is the QR channel barcode. You can scan this barcode to go to the Telegram channel where I send all the links of the video, all the notes, announcements, all the practice sheets, everything I send on this channel. You can join this channel for all these updates. Okay, if you haven't yet. Let us start without wasting any time. So, today we are going to do nitrogen containing compounds. Mainly, we are going to do amines. So, amines. Let me change the color of the pen. Yes, amines. What are amines? Amines are basically derivative of ammonia. We have ammonia as NH2, and suppose I take here X. If this X is equals to H, we call it ammonia. Yes, but if we replace this X by any other group, suppose any other organic group, suppose we replaced it by amine, methyl group, it becomes amine. And what we call this amine? We name it as alkyl amine. Okay, we name it as alkyl amine. This is the basic nomenclature. Since it is methyl, so we will call it as methylamine. This is not the IUPAC name. This is the common name. So the IUPAC name will be methenamine. Methenamine. Similarly, if it is C2H5 ethyl group and NH2, we will call it ethylamine or ethenamine. Now, these are primary amines, or we can say them as 1 degree amines. I hope everyone is comfortable with English. I will be bilingual, both Hindi and English. But as you are studying in ICSCs as well as CBSE, so I hope you are comfortable with English. In the between, I'll speak Hindi also. Okay. So this is 1 degree amine, that is methenamine. Suppose we have two. Suppose this is E2 Et2N, that is it is ethyl group. So Et2N, what is this? This is diethylamine. Okay, Et3N, triethylamine. Okay, so regarding the structure, if I say this is second degree and this is third degree, if I say about the structure, then see, structure is more or less similar to ammonia. As we all know, for ammonia, if I say ammonia is pyramidal in shape, this is ammonia. We have lone pair of electrons here. So if I see the lone pair electrons and the sigma bonds, then one, two, three, three sigma bond and one lone pair. And we already know with three sigma bonds and one lone pair, the steric number is 4. The geometry is tetrahedral. I'm not going into chemical bonding much, but I have to tell you this. The steric number is 4, the geometry is tetrahedral, and the shape is pyramidal. If I tell about the hybridization, then 3 sigma and 1 lone pair makes sp3 hybridization. Okay, so it is sp3 hybridized. Similarly, if I replace these H with methyl groups, it won't make any difference. The shape will be pyramidal only. The hybridization will be sp3 only. There are some angular repulsions, but we are not going into details. Okay, just we have to know from the outer structure only what is they are trying to say. Moving on to the next topic, that is, also we have done structure of amine, and I have told you the nomenclature also. Now, moving on to the methods of preparation, MOP, that is methods of preparation of amines. Let me see if there is any comment. So no one has any doubt. Let us move forward. Let us move forward. Okay. Methods of preparation. First method of preparation is from reduction. This is the basic method of preparation and reduction of nitro compounds. Reduction of nitro compounds. This is the first method of preparation where we take a nitro compound and reduce it from 10HCl. We can use FeSCl. This is a reducing agent and it get reduced to an amine. Okay. Along with hydrogen, and here we get water as a byproduct. Second reaction is ammonolysis. Suppose we have this alkyl halide and we add ammonia. It undergoes ammonolysis. We have ammoniated free electron, which is deep blue in color. It is asked in competitive exams such as NEET and JEE. It is not asked in the board exams. We get amine. This is here ammoniated electron will be released. Ammoniated electron, and the color will change to deep blue. Okay, and NH4. Oh, sorry. Uh, is an excess. this plus NH4 negative positive X deposit. Next, we move on to reduction of nitrile RCN. If we reduce them with hydrogen in the presence of nickel, it get reduced to a primary amine. Or we can use sodium E2OH. ET is C2H5. This is more commonly asked in the exam. On the arrow Na and ETOH is given, you have to identify that the reaction the examiner is asking for reduction of the compound. Okay, I hope this is clear. Moving on, moving forward. Next is here you can add LiAlH4 also. Okay. Next reaction is reduction of amide. If we have any amide, so we have seen reduction of nitro compounds, reduction of nitriles. Next is reduction of amides. If we take any amide and reduce it using LiAlH4 in the presence of dry ether, it get reduced to RCH2NH2 plus H2O. Okay, it gets reduced to RCH2NH2 plus H2O. Next reaction, please mark it, very important. Let me mark the important ones here. Okay, so this is very important, used in convergence. This is very important, used in conversions. And the next one, which I am going to tell you, please mark it as very, very, very important. This is not only asked in these board exams, but also in the competitive exams. Okay, this is an example of a chain shortening reaction. This is the chain shortening reaction. Whenever we don't want to shorten the chain in any conversion, we use this reaction if amine is given. Sorry, amide is given. This reaction is known as Hoffman bromamide reaction. Hoffman bromamide reaction. What do we do in this reaction? We take an amide. Along with amide, we take bromine and NaOH. You have to balance the reaction, otherwise the examiner will deduct your marks, because this is a standard reaction and not any conversion. So if an examiner asks for any specific reaction, like write a short note on Hoffman bromamide reaction, so you have to balance. You can exempt balancing in the case when there is conversion or arrow based questions, but if the examiner is asking specific reaction, then you have to balance the reaction. There is no other choice. So we have R NH2, R and NH2. So we have chain of 2. If R, suppose R is methyl, so we have had chain of 2, and here that CO is lost, so one carbon we are getting less here in the amine. Then Na2CO3, NaBr and H2O. You have to cram this reaction as it is. There are no if and buts here. Okay, we have 4 Na, so 2 here and 2 here. Let me see if it is balanced. 2Br, 2Br, 2Na, 2Na, 1 carbon, 1 carbon, 1 nitrogen, 1 nitrogen, and oxygen is are 2, oxygen are 4, and 1 5, oxygen 3, and 4. One oxygen is not balanced. It will be 2H2O. 2 and 3, 5. And then hydrogen are 4, and here also 4. So equation is balanced. Okay. Next reaction is also an important reaction, which is known as Gabriel thalamide synthesis. Gabriel thalamide synthesis. Do you know what is phthalic acid? Have you heard about phthalic acid? Phthalic acid is like this. This is phthalic acid. If we take the amide of this acid, it will be like this. And in the amide, we add KOH, salt will be formed. Let me form a resonance stabilized ring. This is the salt formation. Then we add any alkyl halide here, for which we are going to prepare the amine. So it will form like this. And KX, salt formation. With the salt, if we take aqueous QH, if we take aqueous QH, then we will get amine here. Let me mark R NH2, R NH2. We'll get RN and 2H. We will get here, and along with this, we will have salt formation like this. This is the entire synthesis. Okay, and marketing is important. It is an important reaction. Now, specific reactions for aniline. Specific reactions for aniline. First of all, reduction of nitrobenzene. We can reduce nitrobenzene using tin, or second is Hoffman bromamide synthesis, where we can use benzamide, and we can reduce benzamide by bromine and KOH. Okay, these are the specific reactions. Moving on to the physical properties. Physical properties of these nitrogen containing compounds, specifically amines. So if I tell about the physical properties, then the amines are mostly liquid compounds. Mostly they are strongly aromatic. Strongly aromatic. Okay, strongly means whenever we burn these compounds, we will give they give a heavy soot formation. If we take any spatula, if we take a spatula and burn these compounds on the Bunsen burner, we burn the compounds, then they burn with a sooty flame, high sooty flame. Okay, बहुत घने घने आपको धुआं देखने को मिलेगा, जिसमें आपका सूट फॉर्मेशन हो रहा होगा, काला काला. If I tell about the smell of these compounds, then the smell is like fishy smell. I have not smelled fish as so much, but the smell is pungent, like a fish, rotten fish. So it has a fishy smell, nitrogen containing compounds. Okay. Next, if I tell about boiling point, then boiling point molecular weight increases, then the boiling point increases. Simple as that. I have given you an example where I told you if a boy stand on its own alone, then anyone can break his strength. But if they if the boys make a chain and go hand in hand, then it will be difficult to disalign them. Therefore, uh, if the molecular weight increases, then the boiling point will increase. Simple logic. Okay. Next is solubility. If I tell about solubility, then all the amines soluble in water due to hydrogen bonding. And this I am talking about aliphatic. If I tell about the higher amines, if I go for the higher amines, then the tendency to undergo hydrogen bonding decreases for higher amines. For higher amines. Okay. So the solubility also decreases because the hydrocarbon part starts dominating in the higher amines. Okay. So the solubility decreases in the higher amines. Next, an important property is basic character. Basic character. As we all know that for acids we see the basicity of the acid, and for base we see the acidity of the given base. We see the acidity of base. As you all know, whenever I told you that check the acidity, what you did, you simply removed an H and checked the stability of the conjugate acid. And we used to say that if the acid is strong, if the acid, if the conjugate base is stable, then the given acid is a strong acid. It has a high acidity of if it has a high acidity, it is highly acidic in nature. The basicity of the acid is more. Okay. So here we check the conjugate acid of the base of the base. There you check the conjugate base of the acid. Here we check the conjugate acid of the base. There you removed an H and check the stability of the negative charge. Here you have to add an H and this check the stability of the positive charge. This NH3 positive. You have to check this the stability of this positive charge over the ring. Okay, as you all know that NH2 group, if it comes in the aromatic ring, it is donating in nature, exhibits plus M effect. Okay, so this also you know. Next, and there you checked Ka and pKa. Here we check the pKb value. Here we check the pKb value. Okay, higher the pKb value, dash the basicity. Filling the blank. Okay, okay. So moving forward. Next is smaller the pKa, pKb, stronger the base. Okay. Next is amines basicity. अमीन्स की ज्यादा होती है अल्कोहल्स, ईथर्स, एस्टर्स, ये सबसे क्यों होती है? बिकॉज दे आर इलेक्ट्रॉन रिच इन नेचर. ओके, so and that nitrogen is electron negative, so what will it do? This you have to tell. इसमें क्या होता है, अमीन्स इलेक्ट्रॉन रिच है, तो जो ये पॉजिटिव चार्ज है, दिस पॉजिटिव चार्ज, इसको इलेक्ट्रॉन की इसको गरीबी है, इसे चाहिए स्टेबल होने के लिए, तो ये इसे पॉजिटिव रिच है तो इसे प्रोवाइड करेगा ये. ओके, दिस इज द रीजन. देयर इज नो एनी नॉट एनी रॉकेट साइंस हियर. नेक्स्ट इज alkyl amines versus ammonia. If we have alkyl amine and if we have ammonia, so I am writing the order, you have to just cram this order. It is this. This is for ethyl. If we have methyl, then just cram this order. There are some exceptions also, okay, for which we have no answer. Okay, so order follows 2 1 3, and here orders follows 2 3 1, like your in English language the rule of 231, second person, third person, first person. Similarly here also 231 for ethyl and 213 for methyl. This is the rule which you have to cram. Okay, we are not going much in detail here. Moving on to the next topic. I hope you are getting what I am trying to say. Next is effect of substituents. You already know effect of substituents. I already told you that it is we have to check the stability of the conjugate acid. So anything which stabilizes this charge, this positive charge, will be more basic. So we have to check the electron donating groups. If there is electron donating group, then it will be more basic in nature, like CH3, OCH3. If the substituent is CH3, OCH3, NH2, so it will increase the basicity. And if the substituent is NO2, cyanide, it will decrease the stability or the basicity. Okay, I'm writing one order and then I will explain you. I am explaining the order for X. Okay, ये है हमारा ऑर्डर. ठीक है, NO2 विड्रॉ करता है इसलिए NO2 का सबसे कम होगा, देन Br Cl एंड ये H मतलब कुछ भी नहीं है, न्यूट्रल. Cl और Br में इलेक्ट्रॉन नेगेटिविटी इसकी ज्यादा है, ठीक है ना. देन Br है आपका और यहाँ पर हमारा H है. ओके, देन हमारा अगर मैं बोलूँ तो इसके आगे आपका आ जाएगा सेकेंडरी वाले जो होते हैं, ये आपके प्राइमरी आ गए, फिर आपके सेकेंडरी शुरू, है ना. लाइक दिस. समझ में आ गई होगी आपको. नेक्स्ट मूव करते हैं केमिकल प्रॉपर्टीज की तरफ. केमिकल प्रॉपर्टीज में आपकी जो सबसे पहली प्रॉपर्टी है वो है एल्काइलेशन. CH3 CH2 NH2 है आपके. अगर मैं इसकी एल्काइलेशन कर दूं, किसके साथ एल्काइलेशन करूंगा? C2H5Br के साथ कर दूंगा. और अगर मैं एक्सेस में करता रहूंगा तो ये CH3 CH3CH2 का होल 4 NBr इस टाइप का दे देगा ये. ठीक है, ये होगा एक्सेस में, टर्शियरी बनेगा, ये बनेगा एक्सेस में. ठीक है, तो ये हो गई आपकी पहली रिएक्शन. नेक्स्ट रिएक्शन सुन लो अब. नेक्स्ट रिएक्शन है एसाइलेशन की. सपोज करो RnH2 है और ये एसाइलेशन में अंडरगो कर दे RCOCl के साथ, ये देगा RNH C डबल बॉन्डो R. अगर डैश ले लूँ तो ये भी डैश हो जाएगा. ठीक है, तो ये इस तरह से RNH और ये HCl, यहाँ से H और यहाँ से Cl निकल जाता है, आपका ये बन जाता है N सब्स्टिट्यूटेड अमाइड बन जाता है. दिस इज कॉल्ड N सब्स्टिट्यूटेड अमाइड. ठीक है, उसके बाद नेक्स्ट रिएक्शन इज, सपोज करो इसमें एक एसिटिक एनहाइड्राइड भी आ सकता है, ये भी देख लो. आ गया ये, नहीं होगा वही HCl ही निकलेगा, मतलब इसमें जो है ये प्रोडक्ट निकल जाएगा CH3COH और आपकी रिंग पे जो रिंग लगी होगी उस पर NH के साथ सब्स्टिट्यूट हो जाएगा ये COCl. ठीक है. Next. Next reaction is carbylamine reaction. ये हम already कर चुके हैं. This we have already done in the first chapter, haloalkanes and halogenes, where this along with chloroform and cuet gives isocyanide on heating. Okay, so this is the reaction. Then the reaction with nitrous acid, not popular one, the presence of NaNO2 HCl, it gives alcohol. Not the popular one. This isn't the important one, but you have already done this reaction. And this is also not new. This is the basic reaction. Okay, moving on to the next reaction. This is diazotization reaction, which is not new to you. You have already done in the haloalkanes and halogenes. We have our aniline, and aniline we take ice cold mixture 0 to 5 degrees Celsius and HONO. Okay, NaNO2 HCl, which gives this HONO, and we get into positive scale negative plus NaCl plus. Okay, next is electrophilic substitution reaction. Since we know NH2 group is electron rich in nature, it will donate electrons to the ring. So it is nucleophilic, so it acts as a nucleophile and it acts on the electrophile. So we have electrophilic substitution reactions in the ring because we know that NH2 group is electron donating. It undergoes plus M effect. Okay, like this. It undergoes plus M effect, and it continues. Okay, you can do the make the resonance structures on your own. Okay, I'm not wasting any time on this. But there is a slight exception. Suppose if you treat it with bromine, you should have got ortho product or the para product. But on the other hand, you are getting a tribromo product. You should have got an ortho product or a para product, but you are getting a tri-substituted product, tribromoaniline. You're getting a tribromoaniline here. This is a surprising fact here. So what should we do if we want to get mono product? हमारी requirement ही नहीं है tri product की, तो what should we do? We should add calcium disulfide. If we add calcium disulfide, then we will get an ortho product and a para product, which we can separate by fractional distillation, or we can do the solvent extraction. Okay, or the column chromatography. Next is nitration reaction. Nitration reaction also we have a surprising fact. Nitration. Here we have a surprising fact too. We are getting ortho, para, and meta all. We are getting all the three products, ortho, para, meta, and I tell you the percentage. Ortho we are getting only 2%. Meta we are getting 49%, 48%, and we are getting para around 51%. So 51 and 53. So sorry, 47. 47%. 47. Meta is 47% and para is 51%. This is a surprising fact. We should have got ortho and para only. And we knew that para will be major, but we didn't know that ortho will be only 2%. This is the surprising fact. So this is a reaction which you have to remember, because a thing which is an exception is asked by the examiner. A thing which is common to everyone, the examiner will not ask that thing. Okay. Moving on to the next reaction. Reaction with uh, what should I say? Sulfonation. So, what is the electrophile here, you have to tell me. This is a sulfonium ion. Okay. So it acts with concentrated H2SO4. So what we get here is aniline hydrogen sulfate. Again, a surprising fact. We are getting aniline hydrogen sulfate, which we have to treat with at 453 to 470 Kelvin. We have to heat. So we are getting a uh, para product. But the reaction doesn't stop here. It doesn't exist in this form. This this sulfanilic acid. It is known as sulfanilic acid. H2 and SO3H. It doesn't exist in this form. Oh my God, this doesn't exist in this form, but it exists as a zwitterion. It exists as a zwitterion. What is this zwitterion? Zwitterion is when you have a molecule with both positive and negative charges. Oh my. What is this? This we will get to study in the next chapter, that is biomolecules. There will be study what is Zwitter ion. So it has both positive and negative charge. So sulfanic acid, this is known as sulfanilic acid. Sulfanilic acid. It doesn't exist like this, but exists like this in the Zwitter ion structure. Okay, this is also an exception which you have to remember, because the examiner can ask this, and it has been asked in the previous years as well. This is the PYQ. When we will discuss the PYQs, then I will tell you that. Remember the session I took on 13th of January where I taught you this. We are summing up the entire chapter in an hour, but we are not leaving anything. Okay, I am covering everything. Just you have to open your ears and listen attentively. And I am damn sure you won't leave any stone unturned to fetch marks in this portion. Okay, I have trust on you, you have trust on me, and we can move on with our chapter. So, next is Friedel-Crafts reaction. Friedel-Crafts reaction is common. This is not new to you. The We have aniline. Then aniline acts with AlCl3 as a Lewis acid, and we know that it is electron rich in nature. It donates electron to the empty orbital of AlCl3, so it will form an adduct. Okay, they form an adduct. And what is the adduct? It is NH2 positive, AlCl3 negative. It just gives an adduct formation. Okay, this is known as adduct. Okay, next reaction is reaction of diazonium salts. I'm not writing these reactions because I have already told you these reactions in haloalkanes and haloarenes. If I take BDC, benzene diazonium chloride, and if I add CuCl and HCl, or CuBr HCl HBr, the reaction is Sandmeyer's reaction, and you get respective alkyl halide. Okay, if there is Gattermann reaction, here we take, in Gattermann reaction we take Cu and HCl, Cu and HBr. Okay, and then if I want to provide iodo, I take Ai. If I want to provide fluoride, then I take HbF4, hexafluorochloride, and it is hexafluorofluoric acid. This is known as the Bal-Schneemann reaction. Bal-Schneemann reaction. Okay. Next is addition of H3PO2, warm water. You get respective uh, aromatic compound. Aromatic compound. Like if you have benzene derivative, then you will get benzene. Okay. Next is treatment with warm water, gives you phenol. All these reactions I have told in haloalkanes and haloarenes, so I'm not telling here. I'm not uh, increasing the length of the video and making things difficult for you. I'm just brushing up the concepts because I have already taught you all these things. I'm not repeating and unnecessarily wasting your time and wasting your time. Next is coupling reaction. If we did the coupling reaction in phenols also, similarly there is coupling here also, but there is a change in the color of the dye formation. In the phenols, the coupling took place and the dye formed was orange red. Here the dye formed is yellowish in nature and the pH also changes here. So we have BDC plus phenol. They undergo coupling at around basic pH of 9 to 10. There you had acidic pH. Here we have basic pH, and there is a formation of a dye. Okay, like this. We have dye formation like this. Okay, sorry. This is for earlier one. This is orange dye. This dye for I had made a mistake. I told you the wrong pH. This pH was for earlier one, which we did in the phenols. This is for phenols, orange dye, and basic pH. For this reaction, BDC and aniline, we have acidic pH. Previously, I told you basic pH, it is acidic pH, and you will get a product as this is the product form. Okay. Next, we have covered everything. Sandmears reaction, Gattermann's reaction, carbylamines reaction, we have covered. Next is the test for amines. First is this azodite test as test for amines. Okay, we get a dye formed. Next test we have is Hinsberg test, where we test whether amine is primary, secondary, or tertiary. Okay, on the addition of Hinsberg reagent, we add benzene sulfonyl chloride. We have benzene sulfonyl chloride along with our NH2R. We add them, it will form a product like this. Okay, this is a salt formation. If it gives a clear solution on acidification, so this is the an alkyl. Okay, this is 1 degree. If it is giving uh, it remains unaffected. If it remains unaffected, if it not giving anything, it is remains unaffected like this. ये यहाँ पे acidification हो गया, इस वजह से negative charge चला रह गया. If it remains unaffected like this in R, so it is 2 degree. और अगर 3rd degree है तो वो रिएक्ट ही नहीं करेगा, कुछ फर्क ही नहीं पड़ेगा उसको. ठीक है, ये insoluble देगा, ये भी insoluble देगा, और इसमें कुछ प्रोडक्ट ही नहीं बनेगा, जो जैसा है वैसा ही रहेगा ये. बाकी आपका एजोडाइट टेस्ट हो गया है ना. ये थी कहानी इसकी. बाकी कोई डाउट हो तो पूछ लो मुझसे, है ना. वीडियो पसंद आई हो तो लाइक करना. हाँ जी, तो वीडियो पसंद आई हो तो लाइक करना, शेयर करना, सब्सक्राइब करना दोस्तों के साथ. चैनल पर नए हो, चैनल को सब्सक्राइब करने के बाद इस बेल आइकन को हिट कर देना, ताकि आपके पास 30 मिनट पहले नोटिफिकेशन आ जाए करे कि हाँ भाई क्लास हो रही है, मिस ना हो आपकी कोई. अब ये सब्सक्राइब करके चले जाओ. आपके एग्जाम में रह गए 50 दिन, और अगर तुम्हारे को चाहिए नंबर 70 on 70, तो आ जाओ मेरी शरण में, तुम्हारा भला हो जाएगा. ठीक है, सब कुछ करा रहा हूँ A to Z. CBSE के अलग PYQs हो रहे हैं, ICSE के अलग हो रहे हैं, मिक्स क्वेश्चन अलग हो रहे हैं, NCERT के क्वेश्चन मिक्स करके ला रहा हूँ, एग्जाम्पलर के क्वेश्चन बढ़िया बढ़िया. कॉम्पिटेटिव एग्जाम में निकाल लो ऐसे क्वेश्चन हैं, मिक्स क्वेश्चन. ठीक है, तो अटेंड करा करो इसे, और बिना सब्सक्राइब करे मत जाना, क्योंकि तुम वीडियो के एंड तक आए हो मतलब तुम्हें नॉलेज चाहिए, इसलिए तुम आए हो। बिना सब्सक्राइब करे मत जाना, सब्सक्राइब कर लो, इस बटन को इस तरह से बस क्लिक कर लो, भाई पैसा नहीं जाता, बस क्लिक कर लो और इस बेल आइकन को हिट कर दो। ठीक है, थैंक यू वेरी मच, गुड बाय, टेक केयर, सायोनारा। मिलते हैं अगली क्लास में जिसमें हम करेंगे इसके क्वेश्चंस। ओके, चलो जी।